All right, next let's take a look at how to find the slope from two ordered pairs. So here's our example. Find the slope of the line that contains the points 4, -2 and -1, 2. To give you a little perspective, if we were to graph something like this, try to draw a straighter line here. Here's my x and y axes. I'm just going to estimate about where those points would be without drawing all the tick marks, but 4, -2 would be about there. I go to the right 4 and down 2. And then -1, 2, I would go to the left 1 and up 2. Okay, so something like that. If I were to draw a line through these 2 points, what I'm trying to do is find the slope of the line that goes through those 2 points. So in other words, I want to find the value of the rise over the run. All right, now I just have a sketch of a graph, so I wouldn't really be able to use my sketch to help figure out what that slope is. So another way of doing that is using what we call the slope formula. So this would be a good thing to write in your notes, the slope formula here. M equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And you might be wondering, well, what are those little 1s and 2s? All right, so any ordered pair always has an x and a y coordinate. And because we end up having 2 ordered pairs, we have 2 x's and 2 y's. So in order to tell the difference between those, if it's from the first ordered pair, we use a little 1. So x sub 1 and y sub 1 come from this first point, or the first set of coordinates. And x sub 2, y sub 2 comes from the second set of coordinates. So for our example, x sub 1 is 4, y sub 1 is -2. X sub 2 is -1, and y sub 2 is 2. And once you've identified that, now it's just a matching game. It's just an equal substitution. So in the place of y sub 2, we're going to place the number 2, because y sub 2 was 2. When we do all the substitutions, we make sure that we are taking the y coordinates and putting those in the numerator. So the second y coordinate minus the first y coordinate. 2 subtract -2. In the denominator, we have those x coordinates. Notice we start with the second x coordinate, x sub 2. So we go over here, x sub 2 is -1 minus 4, goes in the denominator. And once you have things substituted, we just go ahead and do those subtractions. You can use a calculator to double check. 2 minus -2 is 4, and -1 minus 4 is -5. And then the last step is to simplify our slope. Because we're dealing with fractions here, we always want to make sure that we're simplifying our fraction. Reduce it if possible, and in this case, the only thing I could do is to just watch out for my signs. If I have a positive number divided by a negative number, overall, that's a negative answer. So the slope of the line that contains those 2 points, those 2 ordered pairs, is -4/5. If we look at our graph, our sketch from earlier, we can see that our line is falling from left to right. So that would indicate the type of slope that would be a negative slope. And in our case, we did get a negative value to measure that slope. All right, so here is our next example. It says, how do I find the slope from a table of values? So here we have a table where we have 4 different x values and 4 different corresponding y values. So if we were to graph this data, we would plot points matching up each x with each y. For example, 0, 1 would be an ordered pair. 2, 5 would be an ordered pair, and so on. So I'm going to go ahead and label next to our table the x and y coordinates using our little 1s and 2s. So again, the little 1s and 2s just mean it's the first x, the second x, third x, and so on. So this one would be our first x, That's our second x, and I don't need to use the third and the fourth one. So then we have our first y-coordinate and our second y-coordinate. So we have everything labeled in our table. Now we can go ahead and apply that to our slope formula down below. And when I fill this out, I like to start with my slope fraction and my subtractions. Those are always going to be there. All we have to do is figure out the four numbers that go in the proper place. So the y sub 2 minus the y sub 1 on the top, and x sub 2 minus x sub 1 on the bottom. So let's start with y sub 2 would be 5 in this case. It's the second y-coordinate in our list. Then the first y-coordinate was 1. Then move to the denominator. My second x-coordinate was 2. And my first x-coordinate was 0. Once I have those four values in place, I go ahead and do my subtractions, and I simplify my fraction. Now this one actually divides out evenly, so we want to divide it out evenly. 4 divided by 2 is 2. Now you may notice that the slope formula includes the letter m. We use the letter m to represent slope. So rather than writing the word slope equals 2, we can just say m equals 2. So I'd like you to try this one. And every time I pause, answer the question on the screen to move on. So what would we label as x sub 1? Negative 2 would be our x sub 1. What would we label x sub 2? And x sub 2 would be 0. What would we label y sub 1? Our first y-coordinate would be 3. And what would we label y sub 2? Our second y-coordinate is 0. So let's apply our slope formula by substituting in our values. Which number goes in the first blank? 0, because it's our second y-coordinate. Which number goes in the upper right-hand corner, the second blank? 0 minus what? Well, that should be our first y-coordinate of 3. On the denominator, what number would go first? Our x sub 2, or our second x-coordinate, should be 0. And finally, what number goes in the last blank? Our x sub 1, in other words, our first x-coordinate, is negative 2. When we subtract on the numerator, we should get negative 3. In the denominator, we should get positive 2. And you can double check those on a calculator. The last thing we would need to do is simplify our fraction. What would be our simplified slope? In this case, all we're looking at is the sign change, and the negative divided by a positive is a negative number. And we can't reduce the fraction 3/2, so we can leave it as the slope equals negative 3/2.